Welcome to the second video in the APM 3.1 series. In the first video we installed the firmware into the board, we configured the cable that goes into the receiver from the board itself, and we also spent a bit of time setting up the GPS and external compass and doing all the wiring for that too. In this video we're going to make the wiring loom to connect the APM to the servos and the speed controller in the plane itself. And we're also going to talk about the options to actually power the board so that you can have it working without it connected to the USB. Once we've done those two things with the power, we'll connect it to the actual plane itself. We'll install it into the Hobby King Tech Sumo, and we'll go through that and we'll do it on screen so you can see how I'm putting all these cables in. Once we've done that, we'll do the final calibration via Mission Planner to make sure that everything's working okay. And then we'll do our first test flight. So the first thing we need to talk about is power. So to power the APM 3.1, we actually have three different options. It's slightly easier than the 2.6, 2.5 and 2.7 board, the slightly bigger format one, because it gets quite simple. So there are three ways that we can do it, and we'll go through each of them in turn. The first way is to actually power the board from something called a power module. Now this would go between the battery and the ESC, and it has a lead that plugs into the power module side at the side of the APM 3.1. Now that provides plus 5 volts and ground, and also sensing information from the power module itself on the voltage but also the current that's been pulled from the battery. And that's great if you want fail-safes and also things like the on-screen display by things like Mini OSD. That is all you would need to do if you were going to power it from the power module. So that's one way, and that's relatively straightforward. The next way is to actually power it from the speed controller's battery eliminator circuit. So here at the top we have all the wires that are going to come out that go from motors 1 to 8, and it also includes a plus 5 volt and a ground. Now if you're going to apply power via this socket at the top, you have to actually do a little bit of soldering. There's a little jumper here called jumper 2 underneath that you have to solder across JP2, and then that connects the power, the ground and plus 5 volts from the top of the board to the rest of it to power it. Now there has been comments about problems when JP2 has been soldered on the board, so just be careful of that one. And the last one is a bit of a combination of the two and the one that I'm going to use here, which is I'm actually going to use the battery eliminator circuit in the speed controller on the plane, but rather than plug the plus 5 volts and ground into this top connector, I'm going to plug it into the power management socket. That way I can still use what I've got on the plane without having to add extra weight and complexity with the power module, but I don't have to solder JP2. So let's have a look at that very quickly on a diagram. So here's those three options again laid out. So the first option is from the power module, and that's going to plug in the top left hand corner of the board where it says 1 and 3. Advantages to that are that it allows for the monitoring of both the voltage and current that is being supplied from the battery, which is great for telemetry and on-screen displays. But the downside is, of course, we do need that extra module. That module adds weight and is a little bit more expensive as well, but not hugely so. The next way to do it is to use the top connectors, which we'll talk about next in the video, which is how we connect the outputs of the APM to the various servos and or speed controllers. No extra kit needed here. We'll have a battery eliminator circuit on the plane already that we can hook up to. The disadvantages are we need to solder that jumper at the back, and there are reports of problems flashing firmware once JP2 has been soldered. And then the third way is the way that I'm going to do it, which is where I am going to use the plus 5 volts and ground from the existing battery eliminator circuit that's already in the flying wing. I've used these in the past. I know it's got enough power to power the APM and the servos, but that plus 5 volts and ground I'm actually going to plug into the pins at the side, and here's the pin outs for the power module itself, so it's relatively straightforward and simple to do. So now we have decided which way we're going to do it, and for me we're going to use option 3. The next thing we need to do is talk about the cables for the actual outputs at the top. So the next thing we're going to do then is make up the connections that come out the top of the APM 3.1. Now going from left to right, we actually have ground plus 5 volts and then outputs 8, 7, 6, 5, 4, 3, 2 and 1. Now as we saw on the diagrams on the plane.ardupilot.com site, it's pretty straightforward how we've got to wire this up. Connection 1 has got to go to the right hand servo, connection 2 has got to go to the left hand servo, and connection 3 has got to go to the signal pin of the speed controller. Now that's relatively straightforward and easy to set up, but now we've also got to have the plus 5 volts and ground coming into the power module as well. So that means that we've got to think about how we're going to create this wiring loom. So the first thing we need to think about is the different elements that we've got to connect up. So we have the APM 3.1 in the middle, we have a servo on the right and a servo on the left, and the speed controller itself. We already know that we can plug in inputs 1, 2 and 3 into pins 1, 2 and 3 on the output at the top of the board, so that's relatively straightforward. And the challenge then is, what do we do with the power? Because the power can't run through the APM 3.1. It isn't like the larger versions of the board where we have common ground and plus 5 volt rails on the outputs that you can just plug everything into. So this is going to require a little bit of thought. The first thing we're going to do is we're going to have to connect the plus 5 volts from the battery eliminator circuit in the speed controller to the power module socket in the top left hand corner of the board, as we've discussed, but we're also going to have to connect it to the positive plus 5 volts to each of the servos as well, so it's directly supplying the power. And that also means that for the ground from the battery eliminator circuit in the ESC, we've also got to do exactly the same thing, both connect it into the APM 3.1 so that we're powering the board, but directly connecting each of those to each of the servos so that there is a common ground between all the 4 elements, there's a common voltage, and the signal wires are plugging into the APM 3.1, but the power to the servos isn't being delivered through the APM 3.1. So let's have a look at what that actually looks like in the cable that I've made up. Now again, I've used crimping here. If you're not sure what you're doing with crimping, I'd strongly suggest that you watch the first video in the series where I go through it. So here's the 2 connections that I've made up. First one is connections 1, 2 and 3. Second is for the power module. So there we are. So the first cable is the brown cable that goes into a connector that's marked with number 1, so I know that that's the side it has to go into. The next cable is the light grey. That light grey goes into the second connector, which is labelled number 2. That's the other servo. And then finally, the third wire, which is a blue one, goes into throttle, which I've marked with a T. So again, keeping the ends all clearly marked up, which is going to make it a lot easier when we have to connect it up onto the wing. The complicated part was actually doing the power. So let me try and tease these out so you can see how I've done that. So the way I did this is that I have connected the 3 negatives from each of these connectors together and then have the lead going all the way along back to the APM 3.1 into the power module. And again, the same with the 3 red wires. Try and make it as easy as possible for you to see what's happened. The 3 red wires from each of those connectors soldered together with another flying lead that comes back into the power module socket back on the APM 3.1. So that gives us our signal to the 2 servos on the wing and the ESC throttle signal, but also is going to power the APM 3.1 from the voltage that's coming in from the battery eliminator circuit on the throttle connector, and the power is also supplied that comes in from there straight to servos 1 and 2, so that isn't going through the APM board. So, as with all things APM 3.1, a little bit more complicated than it is for the larger APM 2.5, 2.6 and 2.7, but with this set of connectors, we are finally getting to a point where we can start to put things on the plane. And that's why I'd always recommend, as you're making the looms up, is write what each of the connectors are with a nice Sharpie pen, and then that means that the connecting when we get to the plane to put it in is going to be a lot more straightforward. That's power and control. So now we have the GPS with the compass, we have the receiver connections, we have the connections out to the existing bits and pieces on the plane for throttle and the 2 servos. I think it's time that we drag the Texsumo out and start plugging this in. So here's the Texsumo, and all I've done is I've just pushed all 3 of the cables that we've made so far, the one for the power, the one for the outputs, and the one that goes to the receiver, through the top of the plane. I've just widened one of the existing holes for a cable tie so that they appear in the bottom of the bay. If I just show you what the underneath looks like, it's a little bit tricky because it's quite a big plane. Then there's the receiver and there's the electronics as they are at the moment. Very, very simple. So we have 3 connections into the receiver, 1 going to the speed controller for the motor, and 1 going to each of the servos. Now you can see here I've labelled up the servos as the APM diagram, 1 and 2. That's just going to make it nice and easy for me to fit everything in. And everything that's coming through here, all these wires that we made up in the earlier videos, each of these actually has, so I know that's the aileron, that is a throttle, I know that that goes to number 2, that will go to number 1, and the throttle will go to the speed controller. So the underneath should be a pretty straightforward piece of wiring, and it's just a case of making it all neat. On the top, it's a little bit more interesting. We have to think about where we want to put the APM and the compass. Now I've been thinking about this. Ideally the APM needs to be as near to the centre of gravity as possible for 2 reasons really. One, that's where vibration tends to be the least, but secondly it also is better for the accelerometers to sense the movement. It's not a disaster if it isn't on the centre of gravity, but it helps. Now the centre of gravity on this flying wing is roughly where this spar is. So I'm going to actually mount it here, directly behind the bit of tape that normally has the FPV camera set up on it. This bit of strengthening here, because I actually have a cover that goes on the bottom that provides a bit of support for the electronics underneath, and in front of the support for the motor mount. Now, I have got a little cover coming for this that will provide some protection for it, because being out here it is going to be subject to a lot of abuse, particularly the way I fly this wing. So I'm going to put the case on, so I'm not going to firmly attach it this time. Second thing we need to then think about is where the compass is going to be. I'm probably going to have my compass out here on the wing. Again, I'm probably going to cover this with a bit of tape actually, so it's protected, and it's far enough away from all the electronics, so it's as far away from the power system for the motor and the the wires for the servo and stuff that's out here on the wing, just out of sight. The magnetometer or compass that we're using is on here, so the fact that we've actually mounted the APM 3.1 directly above the 3 wires that go from the speed controller, which is underneath here, to the motor isn't an issue. So connecting it up now we've pushed the wires through is pretty straightforward. I'm going to plug in the receiver stuff, we'll plug in the power stuff, and we'll plug in the outputs. So with a bit of finootling of the wires, it'll sit on the top of the wing like that, which is actually quite neat. Underneath, of course, then we just need to go through and plug in each of the wires into their corresponding socket. Having them all marked up should make it relatively easy. I need to plug these into the bottom of this receiver and these into the outputs. So I'll do that now, and we'll come back and we'll look at it wired up. Okay, so that only took literally a couple of minutes just to wire it up. It's very easy when everything is labelled. So now we have the GPS out here on the wing. I've taken up the excess cables with put a bit of heat shrink on each end just to keep it nice and neat. I'll probably cover that with tape for flight, because obviously I don't want that catching the air. And I'll probably also cover the GPS with a protective cover as well. Or if all else fails, I can put a piece of tape over the top just to keep the wind off it. I've temporarily mounted the 3.1 with that little bit of tape on the top, just so we can kind of see what it's going to look like. Everything seems to fit really nicely now. The only other thing I'll mention is on the 3.1, if I zoom in a little bit, there's a little silver can with 2 holes in it. That is actually the barometer, and we need to make sure that that's protected from wind, because we're flying along. The drop in air pressure from the moving air could be read as a change in altitude. The best thing to do is actually cover it with a little bit of foam. If you've got a case, then pop the foam on top of the barometer before you snap the case closed, or if you haven't, then just stick a piece of foam, a little bit of sponge or something over the top of the barometer, and that will make it work an awful lot better in flight. If I turn it upside down, you can actually see the wiring inside the case. So there is all of the wires coming underneath, plugged into the different receiver channels, and we have actually luckily had exactly the right length for it to plug directly into one of the servo cables that went off to number 2. Oops, sorry about that. And use a little servo extension lead to go into number 1, and that's all connected there and kept nice and secure with a cable tie. So as you can appreciate, hopefully, it's actually really neat when it's on the craft. So the next thing we need to do now is we're going to have to plug this little guy in, connect it to Mission Planner, and just check that we can calibrate it. Ideally, you want the 3.1 as flat as possible. With this being a wing and actually mounted on the top surface, it's slightly tilted backwards. That's not a challenge, but you do need to calibrate it in Mission Planner so it knows what level feels like. I'll do it for the video, and then I'll have to redo it when I put the case on, because that might change the attitude very slightly. We'll also just double check the compass is pointing forward and we've got that mounted correct. Pretty sure I have, because that's what it looked like in Mission Planner when I tested it. But let's connect it up and have a look. So we've had to move into another room so that we've got room to actually move this wing about. It's quite large. And what I'm going to do is kind of show you the wing itself, show you how we've got it set up, and then the final things we need to do before we can go out and try our first flight, because some of it isn't obvious, and I've had a bit of a challenge on my hands over the last couple of hours just getting this to work before I fired up the radio. Now, we're going to use my trusty DX7 for this, and just to show you very quickly, obviously we have removed the prop off the machine. We don't want any uncommanded starts of the motor making life interesting. Underneath, what we've done is we've got all of the receiver. I've also wired in another UBEC to power the board. The reason was I've actually found that the on-board one, the battery eliminator circuit that's part of the ESC, was getting a bit warm. Not overly warm, because it was actually okay, but wasn't happy with it getting that warm on the bench. It was going to get warmer as the servos were doing their jobs in flight. So let me just stop there and I'll show you exactly what I've done to put this together. It's worthwhile mentioning a small modification I've made to the power system on the plane. One of the things I spotted that even on the bench, the linear battery eliminator circuit that's part of this little 20 amp BEC was starting to get a little bit warm. Not too much, about 30-35 degrees, but you could tell it was getting warm to the touch. If it's getting that warm on the bench, there's a good chance that in flight, when the servos are working very hard, we may have a problem where this may overheat, particularly as it's in a slightly enclosed capsule at the bottom of the wing where the airflow isn't great. So to fix that, I've done a couple of things. First of all, we're going to run the model from a UBEC. So I'm actually going to plug this into the power module element on the wing, and I've also unplugged the red cable that goes from the BEC that's part of the ESC. I've pulled that out of the connector, so the 5 volts is coming from this much better switched BEC. So that is what I've done. Just wanted to let you know, although I think this could have probably handled it, I'm not going to risk the plane and having a catastrophic crash for the sake of something like a $3-4 switching UBEC. So let me put this back in the plane and we'll go for our final flight. So if we turn it over now, let's look at the top of the machine. Here we have the APM 3.1. It's actually held on with sticky tape at the moment. The reason for that is the board cover isn't quite here yet, but I do want to do the testing. We have the GPS located out here on the wing, and the slack is taken up with a couple of bits of tape. And then at the front, we're actually going to use an APM radio. So this is going to provide a wireless link between this wing and the mission planner software, so that we can actually do the final setups and testings wirelessly, so I don't have a big USB cable trailing about. If you want to look at how you set this thing up, the APM radio with the APM 3.1, then there's this video here that will take you through every one of the steps. So let's power up the wing first of all. And what you'll notice is the control surfaces will pulse to tell me it's ready. Let me just move the servos around a little bit just to stop some of the noise. Now we are in manual mode at the moment, so as I pull the stick back, both the control surfaces go up. I'll put that there and you can see it. As I put the stick down, they both go down, and they pop up in the right direction. So that's manual mode, and we know it's all working. Interestingly, on this model, what I had to do, I had to actually swap the two servo leads over, but we'll come to that in a second. So let's connect via Mission Planner, and we shall have a look at all the pieces, and we'll connect over the radio link and I'll show you how the setup is done. So here we are connected to the model via the wireless link. Wireless link always has to be 57600, which is why that's different up there. You can see we have a 3D GPS fix. The heading is more or less right. And what we need to do is the final bits of setup. So we're going to go back into initial setup, mandatory hardware, and now we've got everything plugged in, we can run through these final things. Accelerometer calibration we can do very easily. We need to make sure that the plane is level, and then we can click on calibrate level. The way we double check that that looks okay is we go back into flight data, look at the artificial horizon, and as we move the plane around, you should be able to see that the artificial horizon is moving in the right way. And when it's down flat, which isn't quite here because that's off the edge of the table, the artificial horizon looks flat too. Next thing we need to do, back into initial setup, we need to do the compass. Always good to calibrate your compass. We need to ideally select APM with external compass and then click on live calibration. Then follow the on-screen instructions. Again, worthwhile checking when you've done that, go back to flight data and double check that the compass heading, which is the one we're looking at here on the screen, is spot on. So as I move it around, to the left, to the right, you should see the plane moving on Mission Planner. So that all looks good too. Next one we need to do then, go back into initial setup, go into radio calibration, and here we can see the radio all working. It's worthwhile me spending a minute talking about this. As I move the controls, you'll see the bits and pieces moving in the Mission Planner display. Now, the trick here is we need to make sure that channel 8 changes. So this is the AUX1 channel. So as I change each of the channels, you'll see that value change. We also need to make sure that gear moves as well and that the throttle works. Now, the board is armed, so as I move the throttle, we can see that's working as well. So what we would do is we click on calibrate radio. And then we move the sticks to each of their corners positions, throttle to the top and bottom again, the other control switches, and then we're all set. And then we can say click when done. Now, to make this work, what I found was that I had to change a couple of things here. You have to click, obviously, elevons because it's an elevator and aileron mix on something like a wing, so we had to click that. And I also had to reverse elevons channel 1. Now, there is a process on the website, put the slide up here, that talks you through what you need to do. The trick I found when I actually tried to use it with the APM 3.1, I found that although the aileron was working fine, the elevator was reversed. So rather than when I pulled the stick back, the control surfaces come up like they do now, they were actually going down. Now that was a real nightmare to try and fix, and the way I ended up fixing that was by swapping over the two connections. So this should be 2, that should be 1, or vice versa, and I swapped them around and that really helped. The last thing you need to do then is to check whether or not they're moving in the right way. But before we do that, let me show you flight modes. So that channel 8 that we have connected to auxiliary 1, as I flick the switch, you'll see that at the moment it is set to manual mode. As I flick it once, I've set it to fly-by-wire A, and again, if I flick it, I've set it to return to launch. So at the moment, I have 3 modes available. Fly-by-wire A is what we need to engage to make sure that the plane is behaving properly. So let me put it into fly-by-wire, go back into radio calibration, and now I can still move the control surfaces. So pulling the stick back takes the control surfaces up, left and right, but the plane will compensate for any uncommanded movement. Now the way to check this is, if it's going to be kind of difficult to do this, let me just move the camera and I'll check it. So here we are looking at the back of the plane, and the way it should work is that if you tip the plane down, the control surfaces come up. If you put the plane up, the control surfaces should move down to correct it. And similarly, if you move it from side to side, the control surfaces, I don't know if you can see that very well, should move to compensate for the roll as well. And that's what you're looking for, it to correct for the movement that you're doing. So when you lift it up, I don't know if you can see that, but the control surface is going up and down. If you tilt the nose up, it goes down. If you tilt the nose down, it goes up. So you need to make sure that the control surface is correcting either way. This was the bit that took me ages. I eventually found that for me, swapping over the 1 and 2 channels really helped, and making sure that elevons was clicked, of course, because we're using them, but reversing channel 1 was the trick. If I unreverse it, you might notice now that the control surfaces don't work in the right way, and that'd actually be fighting each other. So that's all done. So now we're at the point where we can actually take this down to the flying field and maiden it for the first time and give it a go. So thanks for watching. Please like, subscribe, and happy flying.